Hi everyone. What we are going to introduce today is unsafe deserialization. Why, if this vulnerability exists in your program, how can hackers take advantage of this vulnerability? The video screen you are currently seeing is the unsafe deserialization vulnerability was scanned out by Fortify's Eclipse plugin. I just clicked on the unsafe deserialization node in the upper left window, and the Fortify plugin will jump to the sync of the vulnerability. In this demo program, the sync point is in the 49th row. And now, we keep going to trace this program from the source point. The 38th line of the program gets the parameter payload of base 64 from the front end. The next line of code just removes the unnecessary control characters new line and tab of the payload. On line 43, convert the payload obtained from the front end from the base 64 string back to the byte array. This line just prints byte array for debug. Let's continue to look at line 46. The program converts byte array to object input stream through byte array input stream. Finally, the sync line we saw at the beginning, because the data we obtained from the front end to the sync has not been validated at all, so it has caused unsafe deserialization vulnerability. Let's move on to the second program. The next one to introduce is the serialization program. At the beginning of the program, the message object was created and set some values. Then create object output stream object through byte array output stream object. Then use the write object method to serialize the myMessage object. The byte array converted from myMessage serialization can be taken out by byte array output stream object. Finally, we encode the byte array by base 64 and print it out to the front end. Engineers with experience in serialization programs should know that the results generated by this serialization program cannot be handled by the deserialization program we introduced earlier, because the two programs introduced earlier are not compatible. If the package generated by our serialization program can be used by the deserialization program, it can prove that the deserialization program is not safe. So I wrote a third program to modify the packet generated by the serialization program to make the packet can be accepted by deserialization program. Let's see what the program does. First, we get the payload from the front end. Then remove unnecessary control characters. Then, in order to let everyone know what we have done, we directly print the characters obtained from the front end. Please note that this is a dangerous way of coding, which will cause cross-site scripting. Then we convert the payload obtained from the front end into a byte array using base 64 decode. On line 41, we convert the base 64 string back to a byte array in order to modify the packet. The next two lines just print this byte array to the front end, so that everyone can compare the difference between the package before and after modification. The makeMeterPreter function is the main part of this program, which is where the packet is modified. The next two lines print out the modified packet to the front end in hexadecimal format, so that everyone can compare it with the packet before modification. At the end of the program, I encode the modified packet with base 64, and then write the base 64 string to the front end. Finally, let's look at how the main function makeMeterPreter of the program modifies the packet. We copy the first 7 bytes to the new array without modification. The 8th byte is the length of the class name, followed by the class name including the package name, because we don't need to change the package name. So in line 60 we directly copy the package name from the original packet to the new one. The actual process of modifying the class name is only on line 61. We directly convert the response into a byte array and copy it to the new package. In the end, we didn't want to modify other data, so just copy the remaining data from the old packet to the new byte array named bin. Let's take a look at what is in the message class used by the serialization program. There are two string member variables, author and message, and two member functions, setAuthor and setMessage. The last two methods implement the serializable interface. The methods only print debug information to the console. The last class is response. This class is used in the deserialization program. Let's take a look at the content of the class. The first two string members are exactly the same as the message class. The next two setMessage methods are also exactly the same as the message class. The getMessage method is the only member method that the message class does not have. The methods of the last two implement serializable interfaces are also the same as the message class. Let's continue to look at the three HTML programs of the front end. First, look at serialization.html. This program has only one form and one submit button. Next is deserialization.html. Compared with the previous program, there is one more text area element. Compared with the previous program, the last HTML is only different in the action attribute. Finally, let's take a look at the execution results of these programs. I will open the 3HTML before executing it. The serialization.html program will serialize the message object after push submit button. I copied the base 60 for string generated by the serialization program. Let's open the deserialization.html program then. Paste the base 60 for string just copied to text area and press submit. We already know that the two programs are incompatible, so the occurrence of exception is within our expectation. The exception tells us that class message cannot be cast to class response. So if we want to make the deserialization program acceptable, we must modify the packet. So we use makeMeterPreter.attl to modify the package. I paste the base 60 for string I just copied to text area, and then push submit. You can see that this program prints out two parts: the original base 60 for string and the hexadecimal code of the original packet in part 1, and the modified packet MeterPreter in part 2. Let's look at the hexadecimal part. You can see that the original packet class name is message. The class name of MeterPreter has been modified to response. Then copy the modified base 60 for MeterPreter string. Back to the deserialization program. Paste the base 60 for string I just copied to text area, and push the submit button. We found out that it actually managed to execute. Our demo this time proves that the Java serialized package can indeed be modified, so you must be very careful when writing deserialization programs, especially when executing important processes or programs that are written in a more flexible way, which make a serious consequence